Good day. The purpose of this video is to go through the creation of a gauged sheet metal template. We will start with an empty template, which is provided within Autodesk Inventor, and then add a few gauge values into the sheet metal styles chart. From that, we will then be able to select the various gauges at any time as opposed to continually adding individual gauges one at a time. The process will be done in ANSI standard. However, all the points that will be shown can also be done in the isometric standard. So with that said, let us begin. If we take a look at the chart that we're showing at this moment, it has gauge sizes, standard gauge sizes for stainless steel, galvanized stainless, or sheet steel, which is mild steel, as well as aluminum. We have on this chart the equivalent in inches as well as millimeters. For our purposes, we will be using the inches, the ANSI standard, to go through the process and then create our own template. The values that we will be inputting will be the following. We will be inputting standard or mild steel 14 gauge, mild steel 12 gauge, mild steel 10 gauge, and mild steel 22 gauge. So we will be creating 3 or 4 separate gauge styles in the templates and showing how we can then use these to make changes to our designs on the fly by using this template. Also take note that the gauges that we will be adding to the templates can actually be increased upon. So I can always open up the template afterwards and add more and then simply overwrite the original template to continue this process. So with that said, once again, let's start. So we are now in Inventor. We are in the sheet metal project, and we are going to start, first of all, by firing up a sheet metal part. So I'm going to activate the sheet metal part, the IPT. The IPT sheet metal and the IPT standard are identical. The only difference is that the sheet metal starts after we finish our sketch. It actually enters into the sheet metal tools as opposed to the 3D tools. We can switch to the 3D tools by just simply going up into our tabs and clicking on the 3D model, and it will also allow us to use the 3D tools. However, we are going to go into the sheet metal tools. We're not going to be drawing anything. However, what we are going to do is we are going to be going into the Styles Manager to facilitate this. Now, we can do this in a few ways. Probably the easiest way, because we are in the Home tab for sheet metal, is simply going into the default setup. So if we go into the default setup, okay, we're able to go, as we can see, sheet metal rules. We just click the little pencil on the right hand side, and this will take us directly into the styles editor. A separate way, if need be, is to go into the Manage tab and then select off of the standards and styles and standards panel the styles editor, which will bring us to the same location. Okay, so take a quick little tour of the editor itself. The editor comprises of 2 specific sets of rules. The first rule is the sheet metal rules, which indicates gauges, bends, corners. And then the second rule is what facilitates us establishing a Kfactor. The Kfactor is the constants that is used to allow us to calculate, or allows the system to calculate, the correct allowance and compensation in order to get the correct size for the flat pattern. We're going to be leaving the unfold compensation rules alone for now, and we're going to be concentrating on simply the rules itself. Okay. On the rule, there are two sets. We have the default ANSI and we have the default millimeter. So in reality, a single template can accommodate or facilitate both. We are going to simply use the default ANSI for this one. And as I said, the same process that we are going through at this point can be also utilized to create an ISO standard gauged template. So for our purposes here, we are going to simply click on New. We are going to give the name of our first gauge. So we're going to call this 10 gauge. So 10GA, and then MS for mild steel. Let's click OK. Let's also add another one. In this case, we will add a 12 gauge. Same thing. Let's add our 14 gauge. And then last but not least, let's add our 22 gauge. Okay. We have now created the individual segments. We're now going to go and make our changes. All of the gauges themselves are standard or mild steel. So, in fact, what I could have done is before I made copies, I could have just made the changes on the material, but this is good practice. So if I go into 10 gauge, click the down arrow, scroll down, I am going to use mild steel. I could also use carbon steel. In this case, I'll use just mild steel for this one to indicate the MS. Okay, and then I will also then input the correct thickness. If we go back into our template for our sheet sizes, 10 gauge is 0.1345. So we will then input in the thickness for 10 gauge. We're going to hit save. Let's go into 12 gauge. 12 gauge, same thing. We'll change to mild steel. 12 gauge is 1046, and you can check it. Okay. Going to hit save. 14 gauge. And 14 gauge is 0747. And then last but not least, because I'm going to have to go check, 22 gauge 0.0299 or 0.03. Okay. So mild steel. Save. So we've now set up our gauges. Default at this point is the current standard, the current style. Some people tend to delete anything that they're not using. I tend to leave the default. Biggest reason, if anything goes wrong with any of your standards, what the default will allow you to do is go back to a proven standard, and you can then rebuild the template as opposed to simply destroying it. Okay? So the only other thing we're going to end up doing here is making some adjustments to some of the relief information. So we'll go to 10 gauge. We will go into bend, and for the bends for 10 gauge, I'm going to change the relief shape from straight, click the down arrow and it shows me the 3 different choices that I have. So I have straight, I have round, and I have tear. Just quickly show what each one is. This is round, that is tear. Okay, on the right hand side of the preview, you also have various settings that you can also make changes, and the preview itself, a leader is used to point to show what value correspondent to the right hand side is used to make changes. Okay, so in our case we're going to change it to round. I'm going to make some adjustments. For example, the diameter of the round relief, I'm only going to want it to be half of the thickness. So I'm going to simply go divide that by 2. The height, which will be on the relief depth, we will just leave it as is. And the remnants itself, for our purposes, let's simply make it thickness. Okay, so the third tab is corner, the type of corners we want. Well, if we have our bends at a round, we're going to simply change the intersection to the same thing. So we will just change the intersection to a round, and as we did before, in this case, it's thickness times 4. We'll tighten it up. We'll make it only thickness times 2. We'll half it. On the 3 bend intersection, we will just leave it as is. So we'll save. So for 12 gauge, same thing. So let's say with 12 gauge, we're going to go through the same process. Again, we could have done the first gauge and then copied and then changed the thickness. I like doing it this way because it gives me the opportunity also to make sure that all of my settings are as they require to be. So let's do that. Just make that 2. Okay, we're going to save. And once again, we're going to go round, divide that by 2, multiply that by 2, and then last but not least, of course, while we're here, we might as well do this. We'll just do that. And then on the bend, round, and we'll divide that by 2. Okay, one last save. So now we've set up our various gauges. All we need to do now is hit save, copy. Okay, so save, close. We have now gone through all of our gauges. We can test to make sure that they've taken by just clicking on the sheet metal tab. On the sheet metal tab, we're going to click on the sheet metal defaults, and then underneath the sheet metal rules, we will just click close, and we have all of our gauges. The Kfactor, if we click on the little pencil, the Kfactor itself is set to an optimized 0.44 unitless. What I have found is that the 0.44 tends to give a slightly inaccurate value. So what I tend to do is I simply make a change to the Kfactor. So the Kfactor in most cases will work very well at 0.35, and it gives a much more accurate value at that particular Kfactor. Now the nice thing about the Kfactor is that 90% of the time all you're going to need is a single static factor. However, the system does allow you to create and hook up to bend tables, which can be generated or imported. It also allows you to create custom formulas for specific materials where the Kfactor itself would not lend itself to a high level of accuracy. So, as I said before, in my case, I find that 0.35 tends for most of the work that I do for sheet metal, it tends to work out very well. So I'm just going to simply save, close. So my Kfactor is now set to that. I'm going to cancel. And then what I want to do is I want to take what I've just done, and then I want to incorporate that as the template. To incorporate it as the template, I'm just going to go into File. I'm going to go Save As, Copy. And then the third choice from the top, Save Copy as Template. When I click on Save Copy as Template, it is going to take me into the location for all of my templates. The location is usually a default within the C drive. The templates themselves can also be placed into various other locations. Also, if your organization uses an archiving system such as Vault, the templates can also be placed within a vaulted system, a mirrored shared drive, which is also reflected and then maintained within the vaulted system itself. In my particular instance, I'm just going to leave it as is. I am going to place it underneath here. I'm going to overwrite the original gauge that I have right there. I'm going to hit save, accept, and now what I have is I have my template. To prove that the template works, I'm going to simply close without saving. When I hit new, there is my gauged template. When I click on that gauged template, I can then take finish, and there are all my gauges. So everything is maintained as is required. And with that said, that is how we go through and create a gauged template for our sheet metal functionality. Thank you for listening.